Okay, so I'm going to go over the first one like I was teaching it, and then I'm going to ask for some of you guys to tell me what you got on the others or what you're thinking on the others. And then we'll do some on our own, and then we're going to do a delta math with that. If we get time, we're going to start the 1.3 notes, but there is a chance that we may not get time for that because we didn't finish it up in second period. So, whenever we are looking at domain, okay, when we're looking at domain, our ruler is going to go like this. So domain here, range, we're going to put our ruler like this. Domain, we're going to put our ruler like this. Everybody have a ruler on their desk. I told everybody to leave them from second period so you'd have it. So you have your own ruler. I know these graphs are too small and hard to see. I'm going to print them different next year, but I hard to print them this time. So if we're doing domain, our ruler is going to go like this. We are going to go across the graph. We're always going to start at the negatives over here on the left. We're going to go across the graph to the right. So we're going to go across, and we're going to just go across until we hit the graph. What we're looking for here is where our ruler hits this x-axis. Okay? So we're not looking at the y's, just the x's. And so what is our x? What is our ruler hitting on that x-axis right there? Negative 2. Okay? So we're looking right here. Negative 2 is where we hit. So negative 2 is our lowest number. And then we're going to go over. We touch the graph, touch the graph, touch the graph. Right here is positive 2. And after that, we got nothing. All right? So positive 2 is going to be our upper number. So for our domain here, get this rearranged here. Transfer the desk. It's easier this way. All right, so for our domain for this one, we have got negative 2 to 2. We're going to use brackets for this because it's a solid line. Unless you see like an open circle, use a bracket. Except for if you're going to infinity, what do we have to use with infinity? Parentheses every time with infinity. Okay. Range. I brought my chair over here so I could. I'm not tall enough for this. Range. We're always going to do our ruler like this, and we're looking at where that ruler hits the y-axis right here. So we're looking at the numbers on the y, not where it is out on the x. So we're going to start at the bottom. Down here we got nothing. We don't touch the graph. Then we're going to go up, up, up. Right here we start to touch the graph. What number do I have on my y-axis there? 0. Then I keep going up, 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 up. Right here's the end of the graph. That's my highest point. What do I have there? 4. All right. So we got 0 to 4. Again, we're going to use brackets because we have solid lines. We don't have any open circles. So we'll have 0 to 4. Okay. Is this a function? No. Okay. How do we know it's not a function? If we got that vertical line there, is it going to touch more than once? Lots of places it touches more than once. It only takes one, but in this case, it's lots of places that it touches more than once. Okay? All right. Questions? All right. So we had a wide variety. Some of you looked like you'd written down confident answers there. Others of you were like, this isn't right. Some of you maybe didn't have it at all. So who is going to be brave and tell me what they got for number 5 for your domain? Okay, what do you got, Silas? I somewhat agree, but we can't just say infinity. I think you mean the right thing for that. But we have to do it, if we're using like interval notation, we have to start somewhere and end somewhere. Up to positive infinity. You also, on this one you could do negative 2 less than or equal to x less than or equal to 2. If you use that notation, that's fine. I usually find students like the interval a little bit better. We're a little better at that, so I'm going to mostly use that. If you want to write this with inequality, you can't really do it because it's just all the numbers, right? So the other way that you can say this is all real numbers. And there is a symbol that we use for that. It is R with like a double bar right here. So that is accepted. So if you ever want to write that instead of doing negative infinity to infinity, you could. It just means that it's all the numbers. All right. Silas, what did you get for the range on that one?
The range was negative infinity.
Also negative infinity to infinity. Okay, is that one a function?
Yes.
Yes. Is it a one-to-one function?
Yes.
Yes, it is one-to-one. That didn't necessarily ask for that, but if we just want to be a little bit of a show-off, it is also a one-to-one. Right. We good there? Questions? It may, yeah. It may. So a lot of these worksheets, have been pulled from different places. You will find North Carolina, back when we switched to the Common Core math and started doing math 1, 2, and 3 instead of algebra, geometry, algebra 2. North Carolina split up their classes for math 1, 2, and 3 different than any other state. So that means that no textbooks, no worksheets, nothing is written for North Carolina because no textbook company is going to write a textbook just for one single state. So most everything that Miss Martin and I have has been pulled from an algebra 2 sort of thing or a geometry thing. So we're pulling it from places where it's not necessarily North Carolina curriculum. So they do talk about one-to-ones with inverses in North Carolina curriculum, but lots of places you don't have to do it. So you will see it on test some, but not tons. And that's one reason why it's kind of, if it ever seems a little bit like scattered and pieced together, it's because it is. Because there are no books for Math 3 in North Carolina. Okay, all right. Let's see. Who can help me with number 6? Anybody want to try? What do you think, Paloma? Okay, perfect. That is your domain. That is great. Range? Wonderful. Infinity always has to have a parentheses. What do I need with the -5? A bracket or a parentheses? Okay, bracket. Very good. Okay. Is that one a function? Yes. Is it a one-to-one function? For a one-to-one, we have to pass vertical line test. We're good. It's good there. For one-to-one, we also have to pass the horizontal line test, which I think is what we did the first day, so you weren't here. But that one is going to touch twice with the horizontal line, so it would just be a function. It's not a one-to-one for that. Okay? Right. Vertical line test tells us function or not. So we don't worry about the horizontal line test unless it's already passed the vertical line test. It's kind of like your permit test. You got to pass it before you even worry about trying to take that license test, right? Unless you're 18, then you don't have to have a permit first. But, all right. Everybody good? Questions there? Maybe you're not good, but you can't think of a question. That might be where we're at. We're going to do some more. Okay. All right. Anybody think they know for domain for 7? Hello? Yes. Adriel, they need you in the office for a minute. Okay. All right. Peyton, what do you think? Domain. Not for domain. Okay. So, for domain, we have got... All right. We got to think this way. Do we have anything over here? No. So, it's not going to be negative infinity, because if it was, we'd be hitting the graph here. So, where do we start to actually touch the graph? 0. At 0, right? So, it's going to be 0. Now, over here, we still touch way out here? Yeah, because we got arrows right there, right? So that goes to positive infinity. So our domain there is going to be 0 to positive infinity. If the only time you do not use the brackets is if you have an open circle. So like if you see over here on number 9, where we've got that open circle, we're going to need a parentheses in a place there. Or if you're using infinity. Infinity always has a parentheses. So otherwise, like if it's a solid line, or if it's like right here where we do have a closed dot, we're going to use a bracket. Except for 8 has something weird. 8 actually has something even weirder. Right there, we'll have to talk about it in a second. All right, so range for 7. What do you think, Peyton? No, because you're still kind of thinking like you're thinking on the x-axis, I think, because like here's one end of the graph and here's the other, and they're both like over here at positive infinity. So that's kind of what you're thinking. Yeah. So what we've got to think about. It's really hard to do this, and the best luck I've had is like actually using the rulers to help us. But we got our brains want to think in like both directions, sort of at the same time. So we got to think just the y-axis. So if we're thinking just the y-axis, we're thinking about this line right here. And we're thinking only about these numbers on the y-axis. So right here, my graph does not touch, but would it if I drew it out far enough? Yeah. It would, right? So, and I think, even if I went way down here, it eventually would touch, right? So that's going to be negative infinity here, and then I go up, touch the graph, touch the graph, touch the graph. Here I've got nothing, but would it touch if I drew that line out? It would, right? And so it's going to go all the way up to positive infinity as well. So whenever we're doing range, we got to think about this horizontal line moving up and down and not left or right. But it's really hard to get your brain to separate those two. There. So this one is negative infinity to positive infinity. Okay. Caroline, is that one a function? For number 7? No. It does not pass that vertical line test. It's going to hit twice, for sure. All right, 8 is weird. One part of it's not too weird. One part of it's fairly easy. The other one's weird, and you at least probably don't know how to write the answer. So, anybody, the domain's the one that's a little bit easier. Anybody have an idea for domain? Paloma? Uh-huh. You would almost be right if these were open circles, right? But what we have here is they actually are closed-in circles, right? So we actually have those values are included there. So as we go across here, we are still touching the graph right there at -1. So that is still part of our domain. And then we go across and we have still touch the graph there as well. So this one is going to be negative infinity to infinity. But Paloma was kind of splitting that up where she did not include -1. And that would be correct if those were open circles, if that was like, if those numbers were not included there. Okay. What about range? Range is weird on this one. Okay? Because let's do what we did before with our line. Okay? We're going to start here. Do we touch the graph? Touch the graph. Alright, right here, do we touch the graph? At 1, we're touching the graph. Do we touch the graph here? In between? No, we got nothing right here. Do we touch the graph here? 3, right? And then nothing up here. So, you might have written, I'm going to write something, don't write it down because it's wrong. You may have written something like this, like 1 to 3, but that would mean all the numbers from 1 to 3, right? Including everything in between. We don't really mean that, right? Because we don't have anything in between. So to write this, We didn't do this yesterday, so if you got it right, then it must be from something else. We would do 1, 3, and we would use these squiggly brackets, which means we're just making a list. So squiggly brackets means we're just listing. We did use this when we did the one that was just dots, right? And we just listed 1, 7, 10, 9, 8, whatever the Y values were. So this is sort of the same thing. We're just listing numbers. Or we can write it this way. We can just write x equals 1. Oh, wait, that's bad. What's bad about that? The x. We're talking about range. It should be a y. So y equals 1 or union y equals 3. So you could do it that way also. Either one of those notations are okay. So if you get something weird like that where it's really just like these two numbers, you want to use those squiggly brackets. Okay. Is that one a function? At -1, right here, it hits twice, right? So this is going to be a no. It's the only place it hits twice. It only happens one time, but it only takes one time to make it not a function. Okay, questions? All right, let's look at 9. Who thinks they have it for number 9? Let's see. Sawyer, what do you think about number 9? For domain. No, so I don't have a positive one in it. What point are you looking at when you get that positive one? This one right here? Okay. So this is something I was noticing and I had not thought of before. A lot of students, whenever we were doing our Delta Math in second period, kept looking at like where it crosses the x-axis. That is not what we want to do. Okay, so let me see if I can kind of like explain this better. Maybe it'll help us on our Delta Math a little better because I had a lot of questions there in second period. So, as we go across, like over here, I don't touch the graph. But would I touch the graph if I extended that on out? I would touch the graph right here, right? Like if I took this line right here and I made it longer, right? Because that's what the arrow does. It means it keeps on going, right? I would cross out here and even like over here, except for I just haven't drawn it out far enough, right? So over here on the x-axis, this keeps on going, so that's going to be at -infinity on the x-axis. Because I'm thinking about where my ruler, so like when I'm thinking about where that ruler is, let me draw that line in right here. I'm thinking about where that ruler is hitting the x-axis. Not where the graph is hitting the x-axis, but where my ruler is hitting the x-axis. And so that would be way out here at -infinity for this side. And then I'm going to go across. Okay, and do I hit the graph? Hit the graph. Ooh, do I hit the graph right here? I do not hit the graph right there. Because what's that open circle mean? It means that point's not included, right? It's all the way up to that point, but it doesn't include it. So at -3, I got some sort of issue. Because I don't hit the graph there. But everywhere from -infinity up to 3, I do have a graph. So I would have -infinity up to -3. And notice I'm getting that number -3. I'm getting it from the x-axis. All the numbers I'm getting are come from the x-axis, which is confusing to kids because you want to look at like coordinates or you want to see where it hits. You want to look at this point right here. So all the way up to 3. Now, right past 3, I start to hit the graph again, right? Like as soon as I cross -3, I hit the graph again. So from -3, so we'll use this union right here, -3, I'm going to go over. I'm hitting the graph everywhere here, right here. is my last point where I hit the graph, right? What is my x coordinate right there? It's 2, right? So you're not looking at like all the coordinates of the point. You're just looking at where this hits the x-axis, which is at 2. Should I use a parentheses or a bracket with that? Parentheses. And that is because it's an open circle. It doesn't include that point. Okay, questions on that? That hole in that graph makes it really tricky because you got to leave out that hole. In second period, whoever answered this said negative infinity to 2. And I really wanted to tell them they were right, but they were just a little bit wrong, right? There. Okay, let's look at range on that one. So, range, whenever I look at my range, right, we'll start at the bottom of my y-axis. I'm looking at the numbers on this y-axis right here. So I got nothing down here. This graph does not touch until I get right here. What is my ruler touching on the y-axis? Negative 2, right? So that's my lowest. Then I'm going to go up, 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 up. Am I touching the graph up here?
What?
I am. It doesn't look like it, but if I extend that on out right here, because I've got this arrow right here, the graph keeps on going up. So I'm touching way over here. Okay, so what is my ruler touching? Well, it's actually not touching because we can't get there, but what would it be touching if I could get there? Positive infinity, because we're on the top. And so whenever you say negative, Peyton, I think what you've done is your mind switched from y-axis, because it's going this way, which is negative infinity. That's your x-axis, which is so hard to do. It happens. But we want to, if you do your ruler, we're up here at the very top, right? So it's a positive infinity. Also, so we would go from negative 2 to infinity on that one. Also, you'll find yourself like Peyton. I would know if I had negative 2 to negative infinity. I would know that's wrong just by looking at it. You wouldn't even have to tell me what the question was. I would know you did it wrong. I wouldn't know if you were doing domain or range or anything. I would know it was wrong. How do I know that's wrong? Just by looking at the answer. This number right here has to be the lowest. And this number right here has to be the highest number. Is negative infinity ever going to be the highest number? Never. So if you ever have a negative infinity, it's got to be on the left side because it's the lowest possible number there is. So because your numbers are backwards, I know it's wrong because the lowest should... Now, if you had done negative infinity to negative 2, I couldn't tell just by looking at the answer that it was wrong. I'd have to know what the question was. But if you had something like 3, 0, something like that, I would know. You've got that one wrong. I don't even know what we were asking, but I know it's wrong because 0 should come before 3 for that. Does that make sense? Is that one a function? Yes. Is it a one-to-one function? No. Okay. All right. I want you guys to try the next 3 on your own. Okay? So try the next 3 on your own. Okay, here's what I've got. Here's what I've got. See if it matches what you have. Notice on number 1, these should be those weird squiggly brackets because we're not saying from -3 up to 2, including everything in between. We're saying just -3 and 2. Or another way you can do it is x equals -3 or x equals 2. You could write it just out like that if you don't like those squiggly brackets. They are kind of hard to draw. They're my least favorite of type of bracket because they're hard to draw. Okay, what questions do you guys have on these? Okay, for 3? All right. For 3, we're doing domain, vertical. Over here, does the graph touch my line? It does not right now, but what if I drew it on out? Would it eventually touch my line? It'd take a really long time, but I think it would eventually hit because it is moving. It's going down, but it's also going to the right, to the left a little bit there. So that means we're going to touch even all the way out here at -infinity. And then as I go across, touch the graph, touch the graph, touch the graph, touch the graph. Over here I'm not touching, but it would eventually touch. So it's going to hit infinity. So that'll be -infinity to +infinity. As you do that vertically, it doesn't touch down here, but again, it's got that arrow, so it would. Same thing up here on the top. You would touch that line, and you touch everywhere in between. So that one would also be -infinity to infinity for that. Or you can write all real numbers. Would be okay. All right, other questions? Yeah. Sometimes seeing the answers on these make you realize what you've done. Okay, so we are not going to do the rest of the problems on here, partially because those graphs are so tiny and we're a little bit behind. So we're going to go to the Delta Math assignment that I have for you guys. So if you guys will get out your computers, and you have not